Hello to you all, welcome to today's tutorial. I hope you enjoy and understand the last video. Okay, on this video we'll be taking care of inverse of 3 by 3 matrix. There are a lot of ways to obtain an inverse of a 3 by 3 matrix, but in this session we focus on the long method, which is very long, or a cofactor, you call it cofactor method or minus method. There are a lot of ways, but as far as this tutorial is concerned, we'll be taking care of two, the long method and the shortest method. So most cases, the lecturer will ask you to use the cofactor method. So first of all, remember in the last video, I said before you can find a inverse of a matrix, it has to be a square matrix, and the determinant of the matrix must not be equals to 0. So we are taking care of 3 by 3 matrix. In this case, let A be equals to 7 minus 2, 4, 0, 3, 5, minus 1, 9, 8. Okay, this is a 3 by 3 matrix. This method is very long, but if you follow it accordingly, it's not a big deal. It's not a big deal at all. Okay, first of all, the first thing we need to do is we need to find the determinant of the matrix. There's a video, I make a video on how to find the determinant of a 3 by 3 matrix, so it's not a big deal for us on this tutorial. So 7, then 3, 5, 9, 8. I would have preferred to go straight, but I still want to take it step by step for you to understand. So then 0, 5, minus 1, 8, then plus 4, 0, 3, minus 1, 9. Now this is equals to 7 in the bracket of 3 times 8 is 24 minus 45, then plus 2 into bracket of 0 minus 1 times 5 is minus 5, minus, which will be equals to plus 5 plus 4 in the bracket of 0 minus 3 times minus 1, which is plus 3. So this is equals to 7 into bracket of is equals to 7 into bracket of this is 21 minus 21. Okay, minus 24 minus 45 is minus 21 plus 2 multiplied by 5 plus 4 multiplied by 3. So 7 multiplied by this is minus 147. Yeah, 740 plus 10 plus 12. This is equals to minus 147 plus 22. This is equals to minus 125. So determinant of A is equals to minus 125, which is not equals to 0. So since the determinant of A is not equals to 0, then we can say A is invertible. No, we are a step ahead. What next now to do is we need to find the minus of A. Minus of A. This pen is not good. Minus of A. In this case, minus of A denoted by M in the bracket of A or N of A. It depends on the test you are using. For reference, let's rewrite our A here. 7 minus 2, 4, 0, 3, 5, minus 1, 9, 8. So M of A, it's another matrix on its own, and it's very simple to get. M11, M12, M13, M21, this to denote the element, M22, M23, M31, M32, M33. Now, to get M11, M11 is corresponding to A11. Is corresponding to A11. Now look at it. To get M11, this is A11. You take this, the elements below it you exclude it, and the element above it you exclude it. Then the determinant of this matrix, of this 2 by 2 matrix, is the corresponding minor of A11. Then determinant of this is 24 minus 45. Sorry, 24 minus 45, that is 9 times 1, which is 45. So M11 is equals to 3 times 8, which is 24, minus 9 times 5, which is 45, which is minus 21. Are you with me? So M12, this is A12. You exclude this, you exclude this. I'm sure we are familiar to this method because we also use this method when we are trying to determine the determinants of a matrix. So this is 0 times 8 minus 5, right? Minus 1 times 5 is minus 5. So M12 is equals to 5. That one is straightforward. So M13, this is the corresponding A13. We take this, we exclude this. Then 0 times 9 minus 3. So M13 is equals to 3 in this case. Let's manage this place. Now the M21. This is A21. We exclude this and we exclude this. So we have something like this. Hope you can see it. So then we multiply 2 minus 2 multiplied by 8, which is minus 16. Then minus 9 multiplied by 4, which is minus 36, which is equals to minus 52. So M22 is equals to, this is A22. We have to exclude this row and this column. So we have 7 multiplied by 8. 7 multiplied by 8 is 56, right? 56 minus 1 multiplied by 4, which is plus 4. Minus we change to plus, which is equals to 60, right? A23. This is M23, I mean. This is A23. Then we exclude the column and the row. So we have 7 multiplied by 9, which is 63, minus, this is minus 1 multiplied by minus 2, which is plus 2, then it should be minus 2, which is equals to 61. Okay, let's manage this place. So we'll turn it over to M31. M31, this is A31. We exclude the column and the row. So we have minus 2 times 5, which is 10, minus 10, minus 10, minus 12. So M31 is equals to minus 22. M32, this is A32. We exclude this and this. So we have this, and this. So 35 minus 0. 7 times 5 minus 0. So we have M32 is 35. M33, this is A33. You exclude this row and the column. So we have this 7 times 3 minus 0 times 3. So 7 times 3 is 21, 0 times minus 2 is 0. So M33 is 21. So I will write the whole of minor of A. Minor of A denoted by this is equals to M11 is minus 21. M12 is 5. M13 is 3. M21 is minus 52. M22 60. M23 61. M31 minus 22. And M32 35. M33 is 21. Now we are a step ahead. Then we proceed. After we get the minor of A, you see it's a very long method. Then we proceed to find the cofactor of A. Cofactor of A. The cofactor of A, it has a formula. You can write it as C of A. It's denoted by C of A or cof of A. C of A is equals to minus 1 raised to the power of I plus j multiplied by what? Minor of A. That's the cofactor. But minus 1 raised to the power of n is positive when n is even and is negative when n is odd. Hope you can get me. So we use a trick in this place. You don't have to care much about this. So to get the cofactor of a matrix, once you get the minor, look at the minor here. You just put positive, negative, positive, negative, positive, negative, positive, negative, positive. What this is doing, I'll multiply the element with 1. Then in this case, I'll multiply the element with minus 1 and repeat. So cofactor of A is equals to minus 21 multiplied by 1 is minus 21. Minus 5 multiplied by minus 1 is minus 5. 3 multiplied by 1 is 3. Minus 52 multiplied by minus 1, we have 52. 60 multiplied by 1, we have 60. Then 61 multiplied by minus 1, we have minus 61. Minus 22 multiplied by 1, we have minus 20. Multiplied by minus 1, you have minus 35. 21 multiplied by 1, you have 21. So this is cofactor of A. Now, after you get the cofactor of A, you take the transpose. That is cofactor of A. Cofactor of A transpose. Transpose is interchanging the row with the vector, the row with the column. Then you have minus 21, minus 5, 3, 52, 60, then minus 22, 21. So this is the cofactor to transpose. This is it. I hope you get it to this point. You know, what are we trying to find? We are trying to calculate the inverse of the matrix A. Now, the inverse of the matrix A is equals to 1 over determinant of A multiplied by the cofactor of A transpose. the cofactor of A transpose. Most people call this the cofactor of A adjunct of A. I don't really know about that, so I'll be using the terminologies I know. So in this case, the inverse of A is now equals to 1 over minus 125. If you can recall, that is the determinant of our matrix. Then the cofactor of A transpose is minus 21, 52, minus 22, minus 5, 60, minus 35, 3, minus 61, 21. And we are done. You can try to do the scalar multiplication. If it's not tedious, you can do it. If it's something that can cancel it out, you can do it. So, and that is all for the log method, cofactor method. Some people call it adjunct method, some people call it minor method. So in the next video, we'll be taking care of the short method. The short method, in 5 minutes, we are done getting the inverse of a matrix, of a 3 by 3 matrix. That one is very simple and very straightforward. You just have to follow. See you on the next one.